Alright guys, so today we're going to be going through chapter 6, lesson 2, and it's a little bit longer of a lesson, so pay close attention and we'll get through it as best as we can. So you should have your chapter 6, lesson 2 notes, and you have just a few pictures to draw, but they're going to be maybe some graphs and stuff, so pay close attention. So let's go to our notes. So we talked about states of matter, okay, already in lesson 1, solid, liquid, gas, and plasma. Now we're going to talk about how we change between those states. So the first term you have is temperature. And temperature is a measure of the average kinetic energy of the particles in a material. So temperature is basically how fast or how slow the average speed, the average speed of energy of the particles in a material. So when they have more kinetic energy, they move more, and that means a higher temperature. If they have less kinetic energy, then they move less, and that would mean a lower temperature. So temperature is just average of the kinetic energy of something. The next kind of energy we have is thermal energy, and that is made up of kinetic energy and potential energy. And here I give you some definitions of the two different types of energy, and I would like you to write these on your notes for thermal energy if you can fit them, maybe off to the side over here. So kinetic energy maybe over here, and then potential energy down here. Kinetic energy is the energy of an object when it's moving. So kinetic energy is moving energy. Particles that are moving have kinetic energy. Potential energy is the stored energy that something has right before it's going to move. And that increases as particles get farther apart. Okay, the next thing that we are going to look at is the melting point. And the melting point of a material is the temperature at which a material changes from a solid to a liquid. Okay, so this is kind of easy to think about. For example, if we are talking about a piece of ice, okay? A piece of ice is a solid, and when you would say you put a piece of ice onto your counter in your kitchen, as it's sitting there, what's it going to do? It's going to start melting. So the melting point is when it goes from a solid, a block of ice, and it starts to melt. That's the melting point when it starts to change to a liquid. And the melting point is also equal to the freezing point. It's the same temperature. So for water, ice melts at 0 degrees Celsius. So when a block of ice gets warm enough to warm up to 0 degrees Celsius, it starts to melt. And here we have a graph that shows changes of state. So this section here from A to B is where an object might be a solid. When it reaches this temperature here and it goes flat, it starts to melt. So the temperature does not change while melting. Okay, temperature does not change. Okay, while something is melting, the temperature doesn't change. That's what the flat spot means. Here it hits 0 degrees and it starts to melt. It has to fully melt and reach above 0 degrees before it can start actually going into the liquid phase. So then the opposite that goes with it is the freezing point. And the freezing point is the temperature at which a liquid changes to a solid. So for example, using the same water, if I pour liquid water into a ice little container and I put it in the freezer, then at 0 degrees Celsius in the freezer, that water will melt and change into ice, which is a solid. Okay? Basically what that means is thermal energy is being removed from the liquid to change it to a solid. So I have my water in my container. It's at a certain temperature. When I put it into the freezer, it's getting colder. That means that heat or thermal energy is being removed. When something gets colder, that means heat is being taken away from it. So the temperature, once again, doesn't change during freezing. It stays constant at 0, but the particles begin to move closer together. And then once they get below 0, then they form that solid. So the relationship for melting and freezing is what you're going to draw here. Okay, relationship for melting and freezing in this box. And you can just do it this way if you would like. So you have an arrow going left, When you subtract minus heat from a liquid, you go from a liquid to a solid and you freeze. So when you take out heat, or you get colder, in this example it's water, will go from a liquid to a solid and it freezes. If you add heat to a substance, in this example water, you will go from a solid to a liquid and that will be melting. Okay, the next one is the boiling point. So the boiling point is a temperature at which boiling occurs in a liquid and is equal to the condensation point. And water's boiling point is 100 degrees Celsius. So the boiling point is basically the temperature where you get the bubbles in the liquid, and it's also equal to the condensation point. So it has a counterpoint just like the other ones do. Okay, so that's going to go in here. Okay, and then you also need to write the definition for boiling right here. I'm sorry, it skipped one. Okay, so boiling is vaporization that occurs in a liquid. So when you see the bubbles in a pot of water, that's vaporization occurring inside the actual liquid itself. Okay, so going back up one to vaporization. Okay, it's the change from a liquid to a gas. So vaporization is when you change from a liquid to a gas. Evaporation is vaporization that occurs at the surface. So when you're boiling a pot of water, when you see just off the surface, those vapors coming off, that's evaporation. And then vaporization continues above that. So then where it has here, example of the boiling, vaporization, evaporation, you can go ahead and draw this box right here. Okay, so you draw a container with water in it and bubbles. Okay, so that's boiling. And then you have vaporization and evaporation occurring here where the particles are escaping from the surface as evaporation and then vaporizing as they go from liquid to gas. Okay, so sorry, condensation is the change from a gas to a liquid. So when you have a gas, over here we have this graph example again. You have gas. The particles are really far apart and moving very quickly. They're going to cool down. Thermal energy will be removed from the gas, and then it will change into a liquid. So condensation is that process. And the condensation point is the point at which a gas changes to a liquid. And that is equal to the boiling point. Okay, so in one direction going up, okay, so the boiling point and the condensation point are the same. Okay, the boiling point is the temperature when a boiling occurs in a liquid, and the condensation point is where it condenses from a gas to a liquid. So you can see that here, they're the same temperature. Okay, lastly we have sublimation and deposition, and these are two fairly interesting things that we have going here. Sublimation is a change of a solid directly into a gas without going through the liquid state. It never melts. So when something sublimates, it is in the solid state, and then it just automatically turns into a gas. There is no melting, there is no liquid state. Deposition is the opposite. So there's a gas that changes directly into a solid without going through the liquid state. It never melts. So in sublimation, you go from a solid directly to a gas. And in deposition, you go from a gas directly to a solid. And there's two examples here that you're supposed to put in your notes. So dry ice is an example of sublimation. So a block of dry ice gives off that fog is what you might classify it as. So in here, there's a bowl with a block of dry ice, and it's giving off all this fog. That's sublimation. So the solid block of dry ice, is sublimating directly into a gas. And then deposition, an example of deposition here is the frost on the leaves of a plant. So the air, the gas of the air, or in this case it would be the water vapor, okay, so H2O as gas, water vapor, automatically goes from being a gas in the air, cools down, and becomes a solid ice on the leaves of the plant without ever going into liquid state. So that's an example of a deposition. Okay, I know this is a long one, and I hope that you're able to get everything easily. And have a good night, and I will see you tomorrow. Bye.